Okay, so welcome back. So in this video, we're going to do problem 2 in those simulation exercises. So now, we assume the client has half the money in a mutual fund and half the money in a bond fund. So as you can see, I'm going to start with my the worksheet that we did for the first video. And this is why I strongly encourage you to set any worksheet up like this and making it as flexible as possible, because all I need to do is a few changes and I'm going to have half this problem done right away. So, for example, now assume the client has half the money in a mutual fund and half the money in a bond fund. The returns on the mutual fund are normally distributed with a mean of 16% and a standard deviation of 9%. So, I can do the mutual fund right away, and all I have to do is change this to 300,000. The mean is 16% and a standard deviation of 9%. And so here, by doing it this way, because of the way I've set up the spreadsheet, everything is done. Here are the returns for a mutual fund that starts with $300,000 and has a mean of 16% and a standard deviation of 9%. I'm already done. Here are those returns. I'm done. I don't have to worry about it. And then the client withdraws between $25,000 and $35,000 a year from each account, and the withdrawals follow a continuous uniform distribution. All right, so all I need to do now is change this to I screwed that up. 25,000 and 35,000. And presto, my withdrawals for the mutual fund are already taken care of. I don't have to do anything, because all of this was linked to those cells. I made the correct changes in those cells, and presto, my mutual fund returns and withdrawals are now completely done. I don't have to do a thing. All I need to do now is the bond fund. So what I'm going to do is I'll start here. I'm going to get rid of all this stuff. You know what? I won't. Tell you what, I'm going to keep this. This will be, say, I'm going to get rid of all this. In fact, what I'm going to do, just to make this clear, is these will be my mutual fund returns. And then what I'm going to do, show you a little trick here, is merge and center that. So this set of years is my mutual fund returns. And then this will be my mutual fund with drawals. Sorry, I can't speak and type at the same time, but then I can barely type to begin with. So, okay, so mutual fund withdrawals, and then here I'll say bond fund returns, and merge and center. And so that means I need to get rid of this. Delete. Okay, and so then the bond fund stuff I'll put right here. So mean, standard deviation, rats. Oh, you know what? I don't have to put in a lower and upper bound, because it's going to same as the withdrawals for the mutual fund. So all I need are the bond fund returns. So the returns of the bond fund are normally distributed with a mean of 6%. So I'll put in equivalent 6, and a standard deviation of 2%. So I'll do that. You know what? I will do this. I'll do lower and upper here, even though they're the same. And the reason for that is because I keep it more flexible this way, right? So in the real world, if the client is going to withdraw more from, say, the mutual fund than the bond fund, by keeping those withdrawals separate, I'm just increasing the flexibility of my worksheet. So the bottom line is, all I need to do now is model my bond fund returns and my bond fund withdrawals, and then add appropriately, add the two returns, subtract the two withdrawals, and presto, I'm done. So, and then what I'll do, just bear with me because I want to put this down, move this, and then I'll start with my 300,000, 1, 2, 3. here's my balance, right? So again, this provides with more flexibility because here, the problem evenly distributes the money between the bond and the mutual fund. But what if there was like 400,000 in the mutual fund, 200 in the bond fund? By linking my bond fund to this, I have complete flexibility. Okay, so at any rate, now we model the returns. So the bond fund returns are, in year one, I take my 300,000 and then multiply that by 1 plus my norm.inverse function, rand, open close, the mean, standard deviation, close the parentheses so the honk doesn't honk at me, hit OK, presto. And then year two is, I better anchor this. So I better anchor that, and then that, and that. Right, because I'm going to copy just the year one down, but year two, I got to link to here times 1 plus norm.inverse. Okay, probability is rand, open close parentheses, mean, standard deviation, close parentheses, hit OK. And then here, anchor, let's see, I don't want to anchor, that's actually bad, my bad. I got to anchor the 8, but here I want to anchor both, the mean and the standard deviation. Completely anchor that because I want to copy it across and down. And actually, I don't want to anchor that because I want that to copy. I wonder. Oh, look. Wait, B8. Oh, my bad. So, in that first homework video, I should not have anchored the B8. My bad. Yeah, J8. So let me clean this up first. So if you've already watched the first video, now you'll know. If you notice that I made a mistake, you were correct. So let me correct my mistake. And hit paste. Yeah, that's right. And then if I go here, yeah, okay, sorry about that, my bad. Okay, so now go back to my bond fund returns. Here we go. So, did I get this correct? No, I didn't. I still have the $ in there. Get rid of it. Okay, copy it across. And now copy, oops, and go down, and I think I did 1,007. Oh, nice. I actually think that's right, too. It is. Look at that. Okay, perfecto. Okay, so there are my bond fund returns. Now, let me copy this. Over here. And of course I need to get rid of this stuff. Delete. There we go. And these aren't bond fund returns. These are bond fund withdrawals. There we go. And of course these follow that continuous uniform distribution, so we're going to use that formula. So this is going to equal my lower bound, right, plus my rand function times upper minus lower. I forgot that parentheses. I hate when that thing honks. Okay, so let's take a look. Did I get this right? Yes. And then here, right, I never want my lower and upper bound, the cells that the lower and upper bounds are in to change. So I will fully anchor these and then copy this over. And of course, copy it down. There we go. And we go to 1007 again. Let's see if I can get close. Oh, not even close. Okay. Paste. All right. And then lastly, well, I tell you what, I'll copy this over. And this would be, you know, total funds, I guess. Total funds. And so this is going to equal the mutual fund returns minus mutual fund withdrawals plus bond fund returns minus bond fund withdrawals. Hit enter. There we go. And here, no anchoring here, right? So here, just copy it over. Voila. Copy it down. And let's get to 1007. Not even close. Not very good at that. Okay, hit paste. Okay, so here are the total funds, and so again I would do the mean. Let's see, number of negative balances, and then the probability. Okay, so this is just the average. No, 1.82, so at least I still have money. Number of negative balances, this is the count if. Okay, so the range is the year 10. The criteria, double quotes less than 0, double quotes, hit OK. So never does my balance become negative, so therefore the probability is going to be 0, but how do I calculate that probability? Well, I take the number of negative balances divided by the total number of simulations, and as always, that is just the count function. Count how many simulations I did, and you can see that the probability of having a negative balance is 0. Okay, well there you go. There is problem 2.